Hello everyone, it's 1 p.m. in the Eastern Time Zone, and that means it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. Thanks for joining us today. I'm your host, Henry Regis. Along with me is CoCoRaHS founder and director, Nolan Duskin. Running the technical side of our program today are Noah Newman and Zach Schwalbe. We're coming to you live from the Colorado Climate Center here at Colorado State University in frigid. It actually went to 7 below this morning. Quite a cold day here in Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we'll be recording it for future viewing on our website. All of our Weather Talk webinars are sponsored by grants from NOAA's Office of Education and the National Science Foundation. Well, today's webinar, we're going to explore NOAA's National Operational Hydrologic Remote Sensing Center, and that's near Minneapolis, Minnesota. They're incorporating your CoCoRaHS snow observations into many of their products, and we're going to find out more about what they do here shortly. Well, we're excited to have with us today Carrie Olheiser, and Carrie has worked for the National Operational Hydrologic Remote Sensing Center, also known as NOHRSC, that's the short way of saying it, since 2002, where she is currently the operations manager and chief of the snow survey program. Carrie's always had a love for weather and snow and naturally enjoys the outdoors. In fact, her interests include boating, camping, fishing, running, and golf. Well, welcome, Carrie. Thank you for taking the time to be with us today.
Well, thank you for having me.
Carrie, tell us a little bit as we start out here about how you got interested in snow.
I was going to say, I actually went to school up in Grand Forks, and I happened to be in Grand Forks when the flood of 1997 occurred, and so just living through the flooding experience and experiencing that much snow really piqued my interest in wanting to learn more about snow and snow hydrology, and that is kind of how I got my start into the world of snow.
Well, that's great. Well, that's very interesting. Actually, being out in the snow, and then your interest gets piqued there. Hey, so let's go ahead and start the broadcast here. Start your presentation, and I see you have your slides up. So take it away.
All right. Well, as Henry said, I work for the National Operational Hydrologic Remote Sensing Center. As he said, it's an easier way to just call it NOHRSC, and we're located in Chanhassen, Minnesota. It's a balmy 22 degrees here today, so a little warmer than you folks out in Colorado. So what I'm going to do today is talk a little bit about our office, how we use snow observations, why snow information is important, and then give you some ideas of how to incorporate our information, where to get it, and those sorts of products. So the importance of snow. Most of you probably woke up this morning to have a slow commute and had some snow to deal with. Others had not, but snow is certainly something that impacts most all of us. And during the winter, over 70% of the western states' snowpack runoff originates from the snowpack. The economic value of snowmelt can be estimated at over $350 billion per year. And winter tourism, that's a huge component of snow. It's over $8 billion per year of an industry. So there's impacts of snow where it benefits us, but then there's also the economic cost of snow. Per year, typically, snow removal exceeds over $2 billion per year. And when you take into account road closures and those sorts of impacts, that can impact us at over $10 billion per day. And snowmelt flooding, over $4.3 billion was the cost of the Red River flood of 1997. And so what our mission is to take all these different types of snow water equivalent information using whatever information we can get from satellite, airborne, in situ observations to get the best estimate of water equivalent so that we can protect life and property and enhance the national economy. And so I'm going to talk a lot about different acronyms, and so I can keep talking about SWE. And so focus a little bit on what is SWE. SWE is the snow water equivalent. Many of us have shoveled our driveways and we have about 10 inches of snow. Well, sometimes that 10 inches of snow is very heavy and has a lot of water in it, and sometimes it's light and fluffy and not a big deal. You can almost use a broom to get it off your driveway. So what we are really interested in is knowing how much water is in that snowpack. And so the SWE is if you would take that amount of snow and you would melt it down, what would be that depth of water? And so really the biggest impact that we're going to talk about is the SWE. So when we first started our office trying to provide more snow information, our main clients were the National River Forecast Offices. So within the National Weather Service, we have different components. We have our forecast offices that many of you are familiar with. Those are the folks that generate the typical forecast of the weather forecasts. And then we also have the river forecast centers, and these are the folks that are responsible for putting together the information for river forecasting, flooding, water supply, and that sort of information. And so we support all the different entities within the National Weather Service, and that was our real driver of who was using our information. But as we started to put more of our snow information out there, we really learned that there's a lot of different users, not just within the Weather Service. So a lot of state and federal agencies use our information, such as the Corps of Engineers, the Bureau of Reclamation, the New York Department of Environmental Protection. They're responsible for all the water supply of New York City, and so they use all of our information to help determine how much water they need to store in their reservoirs to support drinking water for them. And then there's also many private sector folks that have used our information. And one of my favorite phone calls or stories I like to tell is when I first started working here, I received a phone call from Campbell's Soup. And I was kind of dumbfounded of why is Campbell's Soup calling me and why are they asking me this information? And it turns out that they were using our snow cover maps to run their ads. So they would determine if there was snow or freshly fallen snow, they would run their soup ads. So that just, many different ways that people are using our information. And so what sort of information does our office generate? We generate many products, including the snowfall, snow depth, snow water equivalent, snowpack temperature, and snow melt in hourly and daily products at a 1 kilometer resolution, and our data is available over the internet through interactive maps. We do 3D visualization such as Google Earth. We do time series loops. We do regional and national discussions. We do text summaries where we do averages based upon different watersheds. We do point queries, and all of our data, we can either push it or you can pull it from our website. We have gridded data, we have archived data, GIS ready, many, many different formats. And so how do we do what we do? And so we run our national snow analysis. We bring in all sorts of observations, of snow observations that we can get. We'll take observations from ground, airborne, and satellite, and we'll put this into our system in which we call the SNODAS. This is the Snow Modeling and Data Assimilation System. And then we generate our various products. So I will break down each of the different components and talk about the observations, our modeling, and then the products. So when I talk about our ground observations, we bring in any sort of observation that we can get our hands on. That includes all of the Weather Service stations, the federal and state agencies, regional mesonets and surveys, as well as different international agencies. So currently within our database, we have over 58,000 stations that reported within the last week, and we have over 145,000 stations in which we've received some sort of meteorological observation over the years. And so I generated a plot showing all of our reporting stations. So each one of these points is some sort of a station that reported air temperature, precipitation, wind speed, direction, any sort of hydrometeorological information. So this is from last season. And looking at this map, it looks like we have great coverage. We have a lot of observations that we're receiving. But when we start breaking it down closely by the different physical elements, we can see that we have quite a lot less observations when we're looking at snow. Still, the coverage looks fairly good. But then when we actually look at SWE, this is the ones that we tend to focus on, of the snow water equivalent observations, you can see that we have a significantly less number of SWE observations. But if you want to remove all of the stations that are not CoCoRaHS, so that are CoCoRaHS, the stations that we're looking at right here, these are non-CoCoRaHS observers. So if you do the comparison of with the CoCoRaHS observers and without, you can see the huge impact and the distribution of observations that we now receive because of the CoCoRaHS observers. So back in 2006 is when we started ingesting the CoCoRaHS observations. And so in 2006 we had about 4,000 stations that were reporting snow water equivalent. And today we have now more than 9,000 stations that are reporting snow water equivalent. And so the total contribution of SWE stations that have come from CoCoRaHS has increased from originally only 18% to now more than 58%. So more than half of our snow water equivalent observations that we use and ingest into our office are coming from CoCoRaHS observers. So moving on to the next component of our observations is our Airborne program. We run the Airborne Snow Survey program out of our office in Chanhassen. We utilize 2 NOAA aircraft that are flown by NOAA Corps officers. And we have over 2,500 flight lines over the U.S., and we typically fly into areas where we have typical snowpack. And this is an example. This is the Twin Otter aircraft that we have, and the system that we have is that yellow cage that you can see in the back. It's a passive system. The system sits in the back of the aircraft, and it's just measuring radiation. So how it works is we have these predetermined flight lines that have been established by hydrologists and folks looking for more information about snow water equivalent, and each of the flight lines is about 10 miles long and it's about 1,000 feet wide. So we have a total average area of about 2 square miles. And so how it works is it integrates the snowpack. Most of you know that the snow distributes because of wind and redistributes because of the wind. And so you can see great variability of our snowpack over areas. And so we will generate an average snow water equivalent over these flight tracks so that we can take into account areas where we have deeper snowpacks and shallower snowpacks. And how this works is we have that yellow, the box in the back of the aircraft that sits and it's detecting radiation. The ground is always emitting gamma radiation in potassium, uranium, and thorium. And so we always have this signature that takes into account the different types of radiation. And so we have our plane, it'll fly at 500 feet, and it'll fly over the area when there's no snow so that we have this signature. We know what the radiation signature is along that flight line. So then we will go and snow will accumulate through the season, and once again we will fly that exact same flight line at 500 feet at 120 knots, and because there's a direct relationship between how much radiation is actually blocked and absorbed and how much water there is. So if you have more water, there's going to be less radiation. So since we know what the signature is before snow and after snow, we can just do a simple calculation and we can figure out how much water equivalent is actually in the snowpack. Since we're talking about water, it also works for ice. And so this is extremely useful in areas where we have a lot of freeze-thaw cycles, and it gets to be very difficult to take a snow water equivalent observation with that ice lens in the bottom of the snowpack. And so this also allows us to get a better understanding of how much ice is actually trapped on the surface of the snowpack as well. Anytime we do any of these flights, all the information is on our website, and we generate products showing where the flight lines were, where the status is of the survey, how many lines have been flown and in what areas. And then we also do a lot of aerial photography. We're kind of the eyes for the forecasters and the folks that want to get a general feel of what are the conditions, the snowpack conditions throughout the area. So we take all of our photos, and they're also geotagged and geo-referenced. So we have the ability to overlay them into something like a Google Earth, and so that we can see what the spatial distribution, and then click on each one of these to get a better idea of what the conditions are. This is just from last season. This is the Big Sioux River in South Dakota. We also do fall soil moisture surveys. The fall soil moisture surveys kind of give us a good handle on what are the conditions going into the winter. How much water is trapped in the soils before it freezes. So we just completed our airborne survey, our soil moisture data, to give us a good idea of how dry or how wet. That actually was just completed right before the snow fell, so that's a great piece of information for the forecasters. So we've talked about the Airborne program, and we talk about how we fly at 500 feet. And so these aircraft are flying at about 120 knots, about 500 feet. And this is just a bird's eye view. This is one of the flight lines that we actually fly. This is a sample video of the pilots flying through. I believe this is actually in Alaska. So just kind of give you an idea. So they're flying at 500 feet, so they have to follow the terrain as they're going over this predetermined flight line. So then we'll have a good understanding of what are the snowpack conditions. So then moving on to our last component of our observations is the satellite component. We use the MODIS imagery, and we generate a product. It's a fractional snow cover product. So we take a 1 kilometer by 1 kilometer pixel, and we'll tell you how much of that 1 kilometer pixel is actually covered by snow. Is it 100% snow covered, or is it 10% snow covered? This information is extremely useful for us to determine our snow line, to know where there's snow, snow-free areas. But observations are not enough. There's never going to be enough observations and enough people to go out and do a true sampling of our entire country to get a good handle on the snowpack. And so we run our snow model, the SNODAS snow model. And so what it is, it's an energy mass balance snow model. I'm not going to go into each of the little components of the model, but I wanted to hit some of the high points that it does take into account precipitation, the rain and snow, takes into account radiative energy exchanges, turbulent heat fluxes and such. So there are many components of this model. So the model itself, we use a numerical weather model, so a lot of the same models that forecasters are using to forecast temperatures and precipitation. We take those inputs of temperature and humidity, wind speed, precipitation type, and we downscale that so we get it down to a 1 kilometer area. And then we use background information. We have soils. We need to know what are the forest properties. Forests have huge impacts on snowpack and snow distribution, land use and land cover. So we take those model inputs and we put it into our model. And so it's a snow and energy mass balance model that is based off of the Snow model by Rachel Jordan of Corel. Then we also have a blowing snow component, and so that is the prairie blowing snow model. And then we have the radiative transfer model that we also model and have components of. So we run the model and then we generate our outputs, the snow water equivalent, snow depth, snow temperature, liquid water content, sublimation, and snow melt. And so all those observations that I spoke about earlier, we take a look at all those snow observations that we've got into our system of snow water equivalent, snow depth, and snow cover, and we do comparisons of what the model output is. So we'll do those comparisons and then we'll generate our products. So no model's perfect. Everybody knows that models, some do really well in some areas. Sometimes it shifts the storm too far north or too far south, or we get rain and we are expecting snow, or a mix of both. And so to make those corrections, or there's nudging products to make the model the best that it can be, that's when we use those ground observations. So each one of these points that you look at, each one of these dots is representing an observation of snow. And so an example of an assimilation or a model correction or nudging in the upper left-hand corner, that is an output of a snow water equivalent grid. That is our gridded snow information. And then in the upper right-hand corner, this is showing each one of those dots. Anywhere where you're seeing it's blue is showing that the model overestimated compared to the ground observation. The smaller dot, the smaller the difference, bigger the dot, bigger the difference. And then you can see some areas where there's red, where the model actually underestimated. Some of those lake effect areas up towards Chicago, and then at the western edges of the storm. And so we'll take all those observations and we will create a correction field, which you'll see in the bottom left-hand corner, in that correction nudging field. That is then applied to the original state. So those observations have direct inputs and direct impact on making a better snow water equivalent product for everyone to use. And here's an example of the satellite snow cover. This is one of the products that we use to help align where the snow track actually was, and so we could use this as a bounding area of where the actual snowpack was observed. So what happened here? We tried to look at things and we want to have a clear understanding of why is there a difference between what the observations are saying and what the model is saying. And so this is an example where the rapid refresh said that it was freezing rain, and they said that it was snow, but it was really freezing rain. So how do we figure that out? So each one of those dots that was displayed, we generate a grouping of 9 time series plots that we provide all the information such as present weather, model temperatures, observed temperatures, and such. So this is an example on the top here. Anywhere where you see this green, this is showing where we modeled rain. Anywhere in the purple here is where we modeled snow. Up along the top, this is the present weather. This is where the observer made an observation of rain, is where it's red. The green is where it was freezing drizzle rain, and blue is where it's snow. So you can look on through here, and there's this entire period of time where the observer was saying this is freezing rain, but you can see that the model itself was modeling snow. Air temperatures were sitting right at 0, so this is a key example of where we tend to have issues of precipitation typing. Was it rain, snow, mix? And so this is where we have some of those difficulties, and why having these observations make it so beneficial to have the observations for us to really sort out what actually occurred. And so once we'll go through and we'll generate this correction using those observations, we'll come up with our best estimate of snow water equivalent. How that information is actually used, this is an example of how a river forecast center, as I spoke of earlier, these are some of the folks that are some of the key users of our information. They're the ones that do the forecasting for river stage. And this yellow, this is a little busy of a slide, but this yellow zeros here, this is showing what the observed stage. This is what the river really did. This is what the river forecast, what was observed. And then on the bottom here, this is where the blue, this is what the forecast was. So you can see that we completely under forecasted this first peak and underestimated the second peak as well. And so on the top here, this is where you're showing what the inputs into the model were. So this is what the modeled snow water equivalent was into the forecast, the river forecast model. But then they went and made some adjustments using the SNODAS corrected suite. And after you can see here when we've used and updated with the NOHRSC snow information, that the forecast and the observed stage were virtually right on. So by having better snow water equivalent observations and better information, they were directly able to use the information to put it into their forecasts to generate a better forecasted stage. So we've talked about the observations, we've talked about our modeling and assimilation system, so now let's talk a bit about our products. So within our website, we have many different layers and pieces of information to get at. One of the most used components of our website is our interactive snow maps. And so this is where you can use our mapping system to look at different areas, look at different physical elements, zoom in, look at historical information. So what we're looking at here is our snow water equivalent back from yesterday, I believe, and so you can see the system that impacted the northern plains and our area, yes, in the last couple days. And so by selecting the different physical element, this is the SWE change, this is the snow water equivalent change, so you can see where we had our increases in snow water equivalent and where we actually had some melt. And here's our snow temperature. So this is figuring out where the snowpack is cold, where the snowpack is warm. Once you have an isothermal and a warm snowpack, that's where we'll typically experience melt and where you can see some of the rapid melt. And you can see a real cold snowpack is kind of locked in into the northern part of the country. And this is the air temperatures. These are the air temperatures that were used by our model, and you can see this is before some more of the cold air has moved even further south to other parts of the country. So here's another product that we have is our 24-hour total melt. So if you want to see how much melt is expected the next 24 hours or 48 hours, or 72. So really the northern tier of the country where we've got a really cold temperatures, the snow is going to stay. We don't see things warming up and melting here in the near future, at least not in the next 72 hours for sure. And so another product that we have is we can also take a look at our snow precipitation. So this is the total snow precipitation that had fallen on the 12th, but then we also do forecasting, and so you can see what the forecasted precipitation will be. We forecast for 24, 48, and 72 hours. So of all of the different physical elements that you can choose from, there's 62 different physical elements to look at. So you can see what our model inputs were, so what we call our driving data, and what the outputs of the model are. And then you can also take a look at observations. And so you can also see point data through our interface as well. So we're looking at the snow depth for the past 24 hours. And now here's the snow water equivalent. And if you'd like, you can zoom in, and I chose the Twin Cities area, focused on where I'm at. And this is the snow water equivalent, and we had a very sharp gradient of this last event that came through our area. We had over 2 inches of water equivalent on the north side of the Twin Cities, and we had less than a 1/4 inch of water on the south end of the Twin Cities. By having most of these observations through this area are actually CoCoRaHS observers, so it was extremely useful to have those observers to see that sharp gradient and actually be able to depict where those changes and where it went from no snow to significant snow in our model. So here is another example. This is the shallow snow water equivalent, and now I have selected on the left-hand side the different stations that we can take a look at and are labeled. And so each of these different stations, you have the ability to click by going up to this query button, and if you click on each one of these buttons, stations, you will pull up a bunch of time series plots. And so you, in the upper left-hand corner, what you're looking at is this solid blue line, the solid dark blue line. That is our modeled snow water equivalent. And each one of these blue dots, that is an actual observation of snow water equivalent. And you can see this is a great example where we are receiving I did a larger time frame. So what we're looking at here is a weekly snow water equivalent. And so we've always been really hopeful and really have promoted getting one snow SWE observation per week, and we call it kind of the SWE Monday. I know East Coast, they tend to focus on Wednesdays is when they try to get all their observers together, but most of the rest of the country we really focus on a SWE Monday. And so you can see the snow water equivalent observation compared to the model. Values are very close. And then you can see here the blue here. This is the observed snow depth. And the blue line, that is modeled snow depth and density. So we've got our snow parameters, and then we also have our modeled and our precipitation type, accumulated precipitation, our snowpack, temperature and density by layer. This is a profile, so if you took the snowpack and you put a nice slice in it, you could see the snowpack profile where it's warmer is showing, or the warmer colors are showing where the snowpack is warmer. The cooler colors is where there's a colder snowpack, and so this is showing that we've got ourselves a really pretty cold snowpack in place and don't anticipate any melt in the near future. Sorry about that. And then in the bottom left, that is our temperatures, as well as the mean snowpack temperature and air temperatures, then sublimation, different radiative fluxes, and information as well. So there's a lot of information that's within these plots for each of these different stations. So you can either click on each station by using the query tool, or if you look in the upper right-hand corner, there's also an option where you can enter in your time series station. So if you know your CoCoRaHS observer ID, or if you have another station that you're interested in, you can just type in your identifier and it'll bring you to the time series plot. So this is an example. This is from the CoCoRaHS observer in Aurora. This is the last couple days here, and so this is the last event of the snow. And so just another way to get at your snow information. So if you'd like to see your information in another format as an observer, this is another place you can get access to it. So within the information, each of these time series plots, there's images, but if you want the data behind those images, you have the ability to select on the left-hand corner a pull-down will allow you to pull down the data itself, an image or a CSV file. You have this data. We've been running the SNODAS model since 2002-2003 was our first experimental year. So about 2003-2004 is how far back you can get historical information as well, just by changing the time series information on the upper left here, And upper right, you can change your start date and your stop date and get more information. You can also change your units if you're interested as well. And I had also pointed out that we are now doing forecast information. So anything, there's this gray line that you can see within the plots. Anything on the left side, that is showing the model analysis, and then anything forward in time, that is the forecast information. So I had talked about, here's just another zoomed in plot of the snow water equivalent observations. And so if you want to know, you see it on the map, but you actually want to see that data that was used to generate that map, off of our NSA page, I'll show you on the next page here how to get there, all of this information is accessible. And so every day we will go through and we'll generate who are the big snow reporters, who's reported what. So we'll give the top 10 snow reports. But then below that top 10 snow reports, you'll see that there's this listing of station snowfall reports, snow water equivalent, and station snow depth. And so by clicking on each one of those, you will then generate another product that will then list what the station ID is and the amount, date, time, and such for the different physical elements. So that information is accessible through our National Snow Analysis off of the main page on the front there. And so once you go to that point, you'll see within the National Snow Analysis a really neat, another nice statistic that we have is the area covered by snow. And so this is for yesterday. 19% of the country was covered by snow. And so this is a kind of a statistic that we've seen quite a bit used, that 60% of the country, 70% of the country was covered by snow. And so just kind of a neat trivia piece of information. So we have all these different areas that we do for the national, but if you want to zoom in on different areas, we have different regional points that you can click on and zoom in as well, and that'll provide you the information. And you also have the ability to go back in time, once again, to 2002 or to 2003. So each one of these 9 panels that have the water equivalent, their snow depth, average snowpack temperature, and such, you have the ability, if you want to animate, if you want to go and see what the season looked like the last 2 weeks or the last day. So this is an example. This is the last snow season. This is the snow water equivalent animation. And so you can see the systems affecting the area and the snow kind of moving through, melting, and then just continuing to accumulate until we reach peak accumulation, and then things start to melt and retreat and give us our last snow season. So moving on to the next component of our website is our 3D visualization. Not everyone has access to an ArcGIS of some of those different sorts of interfaces, and so we generate all of our products into a KML or KMZ as well. And so that is accessible through our 3D visualization, and this is an example of the snow water equivalent. Snowpack temperatures, where we've got our warmer snowpack temperatures, and we have a possible rain on snow event, then we can have some heightened alert and awareness of that would be an area where we could see some potential runoff and potential flooding. So not only can you get the information from the through the KML through Google Earth, but we also provide the information. So if you'd like to generate it into or bring it into a Google map, you can do that as well.
Carrie, I think I don't know if Noah's already said this, we lost your audio for a bit. Could you go back maybe 2 or 3 slides to where it dropped off? Keep going back a little more. Keep going.
That's it. That's about where it came out.
Yeah, right around there. So
Right
somehow
around
the
here?
audio dropped. Yep.
Okay.
Thank you for doing that.
Oh, no, not a problem. So, all right. So, the next component that I'll talk about is our 3D visualization, and our products are available in various formats. And so, following the 3D visualization link, you can see our products of snow water equivalent, snow depth, snowpack temperature, and surface sublimation in a Google Earth. The KML, KMZs, this is a great way to do visualization if you don't have access to like a Google, to like an ArcGIS or some of those other formats. This is a great way to display the information. So within that 3D visualization, you also have the ability to download the WPC snowfall forecasts. And so this will do the 1-day, 2-day, 3-day, 4- and 5-day forecasted snow precipitation. And so this is a great tool for decision support folks to overlay what are the current snow conditions and what is the forecasted snow conditions. Do we expect more snow, or do we expect possibly some rain on snow event? And so this is just stepping through time. This is an example of where a significant event was for the Great Lakes area. And you can see the extent of the snowpack, and then if we change the layer to actually look at what the average snowpack temperatures are, you can see that we've got areas where we've got a warmer snowpack, and so we've got some rain that is forecasted on snow. And so this is a great tool just to draw awareness to that there could be a potential rain on snow event, so we could have additional runoff and a possible flooding event. So not only can we view these through like a KML through Google Earth and such, is that you can also pull up the information through using Google Earth. So this is just another way to display the SNODAS information. So going back to our main page, on the left-hand side, we've added a new feature that's called Observations Near. So one of the biggest requests that we get is people want to know how much snow fell and where is the snow. And so we have the ability to type in your zip code or your city and state, and it'll pull up the 5 closest observations to the location that you entered. So it'll provide you the information of the ID, the name, and then it'll tell you how much information. And each of these is a hyperlink. And so if you click on each one of these again, it'll bring you to that time series plot, that series of 9 different graphs. So in the last few weeks here, we have made some big changes that we now support the CoCoRaHS IDs. When we first started ingesting CoCoRaHS data, we were getting it through a MADIS. It was a different data feed. So if you are familiar with finding your information on our website, you are probably used to finding some sort of a numeric ID underscore MADIS. Well, we now are storing the information as the CoCoRaHS IDs. So we still have a lookup identifier table that you can see what your old MADIS ID is. If that's what you were used to finding the information from, you can see the translation to the CoCoRaHS ID. We now have the ability that you can go in and type either the MADIS ID or the CoCoRaHS ID in the time series generator or any of that information, and they will be crosswalked. So either one that you'll type in, you'll still get the same information. So this is an opportunity that I wanted to thank the CoCoRaHS observers. They are, without this information, we would not be able to generate the products that we do. And so this is kind of a plug where if you're not already a CoCoRaHS observer, the information is crucial to what we do and supporting decision makers and such. And so if you want to learn more about being a CoCoRaHS snow observer and getting some training information, Nolan and folks have put together a great series of training webinars of explaining how to take a snow observation. It's not an easy thing, but it's an extremely valuable observation, and so we really appreciate those observations and the time that you folks take to support what we're doing. So this is kind of the point where if anybody has any specific questions, there's a lot of information on our website. I went through a lot of the areas really pretty quick, but we do have on our webpage, it's the NOHRSC Science and Technology listing on the left-hand side. There is a great document that does a good job explaining more information about what we do and how we do it. And then there's also some tutorials and some little one-pagers explaining each of the different components of the website as well.
Well, thank you, Carrie. That was a great presentation. We a lot of good information there. In fact, we've put the links. We've got a link already on our website, on the WxTalk website, and we'll be putting some more on today on these different products. I remember hearing that back in 2011 that greater than 50% of the SWE reports came from CoCoRaHS observers, and that is really neat to hear that our folks are actually contributing that much to help with your products. So really appreciate that. One product I really liked seeing was the melt forecast product. I've got a lot of snow in my driveway right now, and looking at that 72 hours. Unfortunately, I just look white in this area. So, but
yep, I think it's going to stick around for a bit.
Yeah. Well, I've got a couple questions coming in, and Nolan's with us. Nolan, are you there? Are you in the background?
I sure am. I have a couple questions, if you don't mind.
You might want to start them off. Go ahead.
Carrie, I'm curious, when you've had a couple days off and you come into the office, what's the first products you choose to look at?
The first product, I will come in and I will take a look at the daily SWE change, and through the interactive maps I will choose the physical element of SWE change, and that's where I can get a good idea of where we've gotten additional snow accumulation and where we've had melt, and so I can kind of see where those active areas are in the country.
That's good. And do I understand correctly, you are pulling Canada data from CoCoRaHS as well?
We are, and so that's been a huge benefit as well, and so we are using the Canadian observations into our system as well.
And then I have to ask this question, even though it's well, I'd like to think that all of our observations are always perfect, but I know that they're not. And my question, well, and furthermore, every day we have new beginners starting who have never done this before. And my question pertains to data quality control. We're, of course, scrutinizing the data and informing observers and hopefully enlisting changes to data that was perhaps entered incorrectly. One of the favorite mistakes this time of year is to measure the snowfall and report that as the day's precipitation. What do you folks do with QC above and beyond what we do with our quality control?
So that's a great question. And so we do not discriminate against observations. We bring everything into our office, and we have found that it's much easier to look at some of the, if you have two observations, to determine what's the good observation and what is the questionable observation, whereas if you have 20 observations in an area, the ones that are questionable are going to stand out much easier. And so when we do our assimilation, it's a very manual process, so we have data analyst folks that are looking at each one of those observations and putting it through its own quality control of looking at the temporal and spatial consistency. So we do our own extra set of quality control on those observations. And so we also are trying to we're looking at each one of those observations, and we're comparing it to a 1 kilometer pixel. Think about how large 1 kilometer is, and think about how much the snow varies along, some of these different areas. So we try to get an idea of, sometimes the observer maybe took a snow observation right next to a tree or some other obstruction, and so it may be a little biased, towards one way or another. Not saying that that's not how much that observer took, it's just maybe it's a questionable observation. So if we have a better idea of what the general picture is of all the observations and all the conditions, it makes it much easier for us to pick out some of those questionable observations.
And likewise, your modeled data, if you want to call it that, gives you a first guess to compare to.
Correct. And so it gives us a good basis of, if someone's reporting 25 inches of SWE and the model said, 2 inches of SWE, probably thinking maybe the observer missed a decimal point.
Well, Nolan, I've got a couple people that have typed in questions. Maybe we can come back at the end if you have another question for Carrie. We'll go ahead and take these real quick. Here's Tom writing in, and he wants to know how many specific routes do you fly in the U.S., and are they listed on your website? Any plans for expanding those routes?
Yes. Our flight line network, we fly, there's about 2,500 flight lines, and the flight line network is available off of the Airborne Snow Survey page. On the left-hand side, there's the Airborne Snow Survey page, and then you'll actually be able to choose the flight line map. It's also available on the interactive map as one of the overlays on the left-hand side. The option there, you can select the flight lines to see where those are as well. So we are always working towards expanding our flight line network. Because of the Missouri River flooding that occurred a few years back, one of the big initiatives came back and was determined that needed more snow information, and so we went and installed, I believe, an extra 44 flight lines in some of those basins to help support. So we're always trying to find different areas where we're needing information and where the observers don't exist, and then we'll supplement with the flight line network. So we typically fly, we have 2,500 flight lines in the country. We don't necessarily fly all those flight lines each year. It's really dependent on where's the greatest flooding risk and where's the greatest unknown. We're allocated only X amount of dollars and X amount of flight lines per year, and so we try to focus on the areas where we need that information the most.
Thanks, Carrie. Here's one from Ted in Missouri, and this is in response also to the to viewing with the flights. Does the radiation dissipate after a prolonged time that is given off or absorbed by the plant life? So he wants to know, but you're not actually giving the radiation. Can you explain that a little bit further?
So what we're doing, gamma radiation has a really long half-life, and so it's always emitting the radiation. It does not change much over time. There is some plant component, but that's very, very small. And so we fly at 500 feet because that radiation that the ground is emitting, that's coming out of the ground, it dissipates as you get higher off of the ground. And so you get less and less radiation will reach the aircraft. So that's why we have to fly at 500 feet so that we get enough radiation to have a signal where we can actually use that information to calculate the snow water equivalent.
Okay, here's a question from Jim, and he wants to know if it snows on a Thursday and melts by Sunday, do you still want the SWE measurement even though it isn't Monday? So any time to give those.
I was going to say any time. If anybody is willing to take a snow water equivalent observation, if there's a significant event, I would love for you to take the observation on the Thursday to get that information. It just gets to be some of these areas the observers are taking a lot of SWE observations, and they have a limited area where they're taking the observation, and so as the winter goes on, you have the ability to pretty much destroy what you're sampling. And so if you take a SWE observation every day, it becomes very difficult to actually find an area that was untouched and not affected by the other observations.
Okay, John is writing in, wants to know, he noticed on your presentation some things were given in Celsius, some in Fahrenheit. Is there a standard that you usually use in the models and so forth?
Our modeling standard is in Celsius, and all of our web page, everything we do, we have the ability for you to choose. So you can either use English or metric units, and so it just depends on where I was in the slides, what I chose, but all of the information is viewable either way.
Okay, thank you. Here's Dave in New Hampshire. He lives in an area that receives overshadowing from typical northeasters there. Typically 50%. How can he be sure that his reports are recorded and used, not entered as an invalid report?
Typically, we'll take we'll take a look at the observation, and if the observer, if he typically is, using that observation and using it, reporting it weekly, we will kind of see the progression of the snowpack, and we'll see that typically receives, less snow than some of the other areas when we have the nor'easter. He can also go and take a look on the website and follow that information on the interactive maps. And he can always shoot us an email and say, hey, you know, this is my observer, and this is a true observation, and just want to, you know, let you guys know that this is really what I have. We look at all of the comments that we receive through our website, and so we will take that information very seriously. So we would appreciate that.
Thanks. And if you just typed in a question, if you could retype it, looks like one of them fell off our screen here. So if your question hasn't been answered yet, if you could retype that, we'll visit that here shortly. Here's Henry writing in, and he wants to know, do you or your models forecast Great Lakes water levels similar to river levels?
We do not actually do. What we do is we'll actually provide the information, and there is the GLERL, the Great Lakes, I don't even know exactly what the acronym stands for. Weather Service is full of acronyms, but the GLERL, they're the folks that deal with the Great Lakes, and they do a lot of forecasting and dealing with the Great Lakes levels, and so we provide our information to those folks, and they use our information in their products as well.
Okay, thanks. Well, anybody else? If anybody else has a question on here, oh, here's Dave in Arizona writing in. That I think that was a question we lost before. Wanted to know about the plane, and does the plane require modification to allow radiation to enter the box?
So the plane itself, we have two. One is a Twin Otter, and the other is the jet prop. And you'll notice that they're both high-wing aircraft. And so all of the fuel, or the majority of the fuel for the aircraft, is above the sensor or forward the sensor. And so really where the sensor sits, there is very little. We actually have a carbon fiber plate in which the system is mounted on. And so it's a very thin system itself, and so that we're not blocking much of the radiation from the aircraft itself. So there are some modifications to the aircraft, and each of the aircraft are calibrated for the system as well. So there are some modifications.
Thanks, Carrie. Well, that looks like all the questions we've had come in. Nolan, do you have a final question for Carrie today? Oh, wait a minute. Here's two more just jumped in. Okay, hold on one second here. We'll get back to you in a second. So Dave Ron in Wisconsin writes, how large does a lake need to be to affect snowfall or other precipitation measurements? He lives on a lake in Wisconsin.
You know, for the actual components itself, the lake effect, you know, there's a huge component. The lake effect can be within our model itself, you know, from the true development of snow and such, you know, small lakes can have an impact, but within our modeling framework, we are looking at, you know, 1 kilometer. So typically if it's less than a 1 kilometer size lake, it won't be impacted or won't be realized within our model itself.
Henry, you muted yourself.
Well, let's try that again. Lloyd writes in from Palmyra, New York, how are the forecast regions determined?
Those different regions that we had, they're physiographic regions, and so they were regions that had like characteristics, and so that is kind of something that we've gone back to. We've considered revisiting those regions or removing the regions altogether. So if anybody has strong feelings for different regions and such, they're based upon physiographic for now, but that's to be determined.
Jerry writes in and he says, what do you do in the summertime? Do you guys just take a vacation when there's no snow? What do you guys do the rest of the year?
Summer is actually a really busy time for us because that's when we get to do a lot of the model modifications and make improvements to the model and do some other improvements and changes. So we're not, we don't really get the downtime, unfortunately.
Okay, Nolan, any last question? You got the last question.
Carrie, again, thanks so much, fellow snow lover. I guess I would just be curious if you ever tire of snow.
Towards the end of the season, I do a lot of the analysis and such, and it gets to be, last winter got to be a long winter. So, but I do love snow. I always come back to it and always look forward to another snow season. So looking forward to the snow season. We've already had a couple good events affect some various parts of the country. So
I have to admit we had more people drop out of CoCoRaHS by late March or so last year than in any previous year. We always tell people that that if they feel that that there's health risks associated with snow and ice observations, to please protect themselves and not worry about the observations. But most people stick with it, and there's a couple parts of the country where we actually get more observations in winter than we do in summer. One of those has always been the upstate New York areas, where folks there live there because they obviously love and are proud of their snow and their big snows. But it was just so interesting watching snow fatigue kick in for the Midwest last year.
it was a long winter. So hopefully this year we'll see how it goes. But we appreciate the folks that stuck with it.
And
Carrie,
just a word to all of our volunteers that whatever part of the country you're in, we were always looking to find new observers and certainly people with the same curiosity about snow as Carrie has, because when you start taking these measurements, you just see how remarkable the variability is, not only in how much snow falls, but its water content, its ice crystal characteristics, and all of these things are important in one way or another. So we appreciate what you do very much, Carrie.
Thank you.
Well, Carrie, thank you for being with us today and taking time out of your busy day. We appreciate that. For those of you who out there who regularly watch our webinars, our next one will be coming up on Thursday, December 4th. Mark that on your calendar, same time. And that one is going to be tsunami science and tsunami warning systems. And we were very lucky to be able to get the Deputy Director of NOAA's Pacific Tsunami Warning Center, Stuart Weinstein. He'll be talking on that. And so we'll have that where you can sign up for that shortly. And then we've got a special webinar. We did this one last year. We'll be doing it again a week after that on December 11th. So mark your calendar. Greg Carbon from NOAA's Storm Prediction Center puts on a really interesting webinar about a review of significant weather events occurring during the year. So this will be the events that have occurred in 2014. You don't want to miss that one. Hopefully you can sign up for that as well. So finally, for those of you out there, when you're signing off today, please take the survey that will pop up on your screen. And until next time, this is Henry Regis for the rest of the CoCoRaHS team here saying goodbye and have a great afternoon.